Python lists are mutable. This means that their content can be modified after creation by inserting and deleting elements as we wish. Let's study the main operations that allow us to alter the state of an existing list. The simplest way to add a new element to a list is by using a method called append. This method can be invoked as follows: listname.append followed by a value in parentheses. Remember that in general, a method is a function with a general syntax reflected here, where we can find a container name followed by a dot character, the method name itself, and a list of arguments in parentheses. In the case of the append method, the value passed as an argument is added at the end of the given list. Let's use a list called names with the 4 strings shown here. If we want to add string Kevin at the end of this list, we may do so with the following code: names.append Kevin. This statement brings list names into a new state in which string Kevin has been added at the end. The computational cost of the append operation is, in most cases, constant, or big O of 1. Once again, this means that adding an element at the end of a list will be equally efficient regardless of the number of elements currently present in the list. While the append method restricts the insertion of a new element to the end of the list, it's also possible to add new elements at any other intermediate position. For this purpose, we need to resort to a different method called insert. This method takes 2 arguments, an index and the value to insert. The index is interpreted as the list position before which the new element will be inserted. For example, let's now start with a list called names with 3 strings set to John, Mary, and Adam, where each element occupies the positions shown here. Let's invoke the insert method with argument index set to 2 and argument value set to Susan. This call asks Python to insert string Susan before the element at position 2, which is Adam. The resulting list, after the insertion, includes names John, Mary, Susan, and Adam, in that particular order. Notice that the index passed in the argument, 2 in this case, may also be interpreted as the position occupied by the new element, in this case Susan, after the insertion. Possible valid values for argument index range from 0 to a value that's exactly equal to the number of elements in the list. In the latter case, the new element would be inserted at the end of the list, mimicking the behavior of the append method studied earlier. Let's try a couple of additional insertions using these 2 corner cases. If we run insert with arguments 0 and Taylor, the resulting list includes Taylor as its first element. Now let's run insert with an index equal to the number of elements in the list, which is 5 at this time, and name Kevin. The resulting list includes Kevin as its last element, as you can see here. The computational cost of the insert operation depends on the position where the new element is inserted. When the insertion occurs at any intermediate position, Python must traverse every element appearing after it in order to shift them 1 position to the right and create the gap for the new element. The best case scenario is therefore an insertion at the end of the list, where no existing element needs to be shifted, yielding a constant cost or a big O of 1. In contrast, the worst case scenario involves inserting a new element at the beginning of the list, where every existing element needs to be moved 1 position to the right. The computational cost in this case is linear, or big O of n. On average, and assuming a set of insertions with uniformly distributed indices, the number of elements to shift would be half the size of the list, or n divided by 2, at each time. Cost expression n over 2 is still linearly proportional to n, so we can state that the average computational cost of list insertions is actually also linear, or big O of n. If you enjoyed this content, you may watch the rest of this lesson at computersciencecamp.com, linked in the description below. You'll be able to follow along with coding samples and problems in our embedded code editor. Drop your questions in the comment section below, and don't forget to like and subscribe to help support the channel. Thank you, and happy coding!